Have you ever stopped and just wondered, how in the world does your computer do all that stuff at once? I mean, you're streaming a movie, you've got 20 browser tabs open, maybe a huge file is downloading in the background, and it doesn't even break a sweat. It really feels like magic, right? Well, what's happening behind that screen is actually one of the most brilliant systems ever designed. So today, let's pull back that curtain and really see how the magic trick works. Seriously, just think about what your machine is probably doing right now. You've got this video playing, maybe a bunch of tabs open, music streaming, notifications popping up. How can one single machine with basically one central brain, the processor, juggle all of that at the same time? It seems totally impossible. But spoiler alert, it's not. So the secret, it isn't really magic. It's just incredibly clever management. And to get our heads around it, we're going to use an analogy that I think makes it all just click. Let's imagine your computer's operating system as the world's busiest, most efficient, high-end restaurant kitchen. All right, so here's what's on the menu today. We'll start with the multitasking magic, then we'll see how a program becomes a process, how that process gets a team, how the whole kitchen is managed, and finally, we'll bring it all together. Okay, let's kick things off with the big secret right away. Your computer, it isn't actually doing everything at once. Nope, what it's really doing is switching between tasks so ridiculously fast, we're talking nanoseconds fast, that it creates this perfect illusion that it's all happening simultaneously. And the master coordinator of this whole high-speed dance? That's your operating system. All right, time for our first key ingredient in this kitchen. Before anything can happen, an app sitting on your desktop, which is really just a lifeless file full of instructions, it needs to come alive. And this is where a simple program transforms into an active process. Now, this is a really, really important distinction. Think of a program on your computer like a recipe in a cookbook. It's just sitting there, right? A passive set of instructions. It can't do anything on its own. But the moment you double-click it, the operating system creates a process. And bam! Suddenly, that recipe has come to life. It's a chef in the kitchen, tying on their apron, ready to cook, and starting to demand resources. Memory, CPU time, the works. So, how does the kitchen manager keep track of every single one of these chefs running around? With a clipboard, of course. For every process, the operating system creates something called a process control block, or PCB. Just picture it as that chef's personal clipboard. It has everything. Their ID number, what they're doing right this second, where all their ingredients are stored in memory. It's the OS's absolute source of truth for that task. And our chef, our process, has a pretty clear life story. First, they arrive in the kitchen. That's the new state. Then they get all their ingredients prepped and they're waiting for their turn at the big stove, the CPU. That's ready. When it's their turn, they're running, actively cooking. But sometimes they have to step away to wait for, say, something to come out of the oven. That's the waiting state. And finally, when the dish is done and served, they're terminated. Their job is over and they leave the kitchen. Every single thing happening on your computer right now is constantly bouncing between these states. Okay, but think about this. What if one chef needs to do a bunch of things for the same recipe at the same time? Like they need to be chopping vegetables, stirring a sauce, and plating a dish. Hiring a whole new chef for each of those tiny tasks would be super inefficient, right? Well, that's where threads come into play. It's time to build a team. So what's a thread? Well, it's like an assistant cook working for our main chef. They're all part of the same process, they're working on the same recipe, and they share all the same ingredients and counter space. A perfect example is your web browser. One thread might be busy loading the images on a page, while a completely different thread is still listening for your mouse clicks, so the page never feels frozen. That is pure teamwork in action. And this teamwork, this multi-threading, is exactly why modern apps feel so incredibly responsive. While one assistant cook is off doing some heavy lifting, like loading a big file, another one keeps the user interface snappy and running smoothly. So the app never freezes on you. It's also just way more efficient. For the operating system, creating an assistant cook is so much cheaper and faster than bringing in a whole new chef with their own separate kitchen space. Okay, let's take a step back. We now have dozens of chefs in our kitchen. Each of them has their own team of assistants, and they all want to use the most important limited resource in the whole kitchen, the main stovetop. That stovetop is our computer's processor, the CPU. So how on earth do you manage that potential chaos? This right here is maybe the most critical job in the entire operation. Here's the thing you have to understand. Chefs don't just stand at the stove and cook nonstop. They work in bursts. They'll cook for a little while. That's a CPU burst. Then they'll have to stop and wait for something else, like getting data from the hard drive. That's an I/O burst. The big challenge for the kitchen manager
is to make sure that super valuable stovetop is never sitting idle. The second one chef steps away to wait, another one should jump right in and start cooking.
And who makes that split-second decision? Well, that's the job of the head chef. In computer terms, we call it the CPU scheduler. This is the true master coordinator of the entire operating system. It looks at that long line of chefs who are ready and waiting to cook, and it decides who gets the stove next and for exactly how long. Every decision it makes directly impacts how fast and responsive your whole computer feels. So what makes a good head chef? How do we judge their performance? Well, we look at a few key things. We want that stovetop to be busy as much as possible, right? We want to get the maximum number of dishes finished per hour. And, of course, we want to minimize how long everyone, both the chefs and the customers, has to wait. It's this constant, delicate balancing act between being fair to everyone and being as efficient as possible. So how does the head chef actually decide who goes next? Well, the simplest strategy is exactly what it sounds like. First come, first served. It works just like the line at a deli. Whoever gets there first gets the stove next. It's simple, it's fair, but you can probably see the problem. Imagine you just need to toast a piece of bread, but you're stuck in line behind a chef who's preparing a massive 5-course banquet. One really long job can hold up everybody else. Okay, so a smarter strategy might be shortest job first. This is basically the express lane at the grocery store. If you have a super quick task, you get to go next. And this is actually proven to be the best possible way to reduce the average waiting time for everyone. But there's a huge catch. How in the world do you know ahead of time exactly how long a chef's task is going to take? You really can't. It's almost impossible to predict. And that brings us to a really common and, frankly, brilliant solution called round robin. This is where the head chef says, okay, everybody gets a turn. Every single chef in the line gets a tiny, fixed slice of time on the stove. We're talking a few milliseconds. If they finish, great. If not, they go to the back of the line and wait for their next turn. This way, nobody gets stuck waiting forever, and the whole system feels super responsive because every single process gets a little bit of attention all the time.
All right, let's zoom out and put all of these pieces together. We've seen the individual parts of the kitchen, from the recipe book to the head chef's game plan. So how does this all combine to create that buttery smooth experience we get every single day?
So here it is, the whole symphony from start to finish. It all begins with a passive program. That's our recipe. When you launch it, it becomes an active process. Our chef arrives in the kitchen. That chef then builds a team of threads, the assistant cooks, to help get the job done faster. And overseeing it all is the CPU scheduler, our masterful head chef, who juggles every single one of them, deciding precisely who gets the stovetop and when. It's a beautiful system.
And really, that's the heart of what your operating system does every second of every day. It's not a magician pulling a rabbit out of a hat. It's a master manager. It's an elite head chef, orchestrating this beautiful, controlled chaos that makes something that should be impossible feel completely effortless.
So the next time your computer feels instantaneous, you're streaming a movie, dozens of tabs are open, everything's working perfectly, just take a second. Which part of this invisible kitchen symphony will you appreciate the most? Will it be the chefs and their teams of assistants working in perfect harmony? Or will it be that incredible head chef making thousands of split-second decisions just to keep the whole show running? The magic is absolutely real, but now you know how the trick is done.